So we will talk about uniform consensus. Uniform consensus. So if we look to the algorithms that we just described, we still are using a perfect failure detector, and we just move our decision, this decision, to the end. So that's what we have done. So what is the algorithm now? Every node executes this code, and the code, you have your initial input, you move into rounds, from round 1 to n, the number of processes in the system. And if you are the leader of a round, it means that your process ID is the round ID. Then you broadcast the message to all processes. That's all. And every node, the leader and the non-leaders, perform a collect operation. The collect operation is waiting for the value at round R, and the value is the value proposed and the round number. And then you update your value, basically. So if we just move then, as I said, the decide to the end of the execution, we actually get a uniform consensus algorithm with a perfect failure detector. So let us look now to the execution of the algorithm in the case that our failure detector is not perfect. So we are talking about an inaccurate failure detector, and we first are going to see an execution of the so-called regular consensus, where you immediately perform decide in your own round. And we will start by having the following assumption. Assume our failure detector is not perfect. Processor P2 suspect P1. So P2 suspect P1. And P3 suspect P2. So let us see what's going to happen now. We are in the first round. In the first round, the process P1 owns this round, so he will decide on his own initial value. He will broadcast the value to P2 and P3, as we can see here. Now remember that P2 is suspecting P1, so P2 can actually move to round 2 because of his failure detector says P1 has failed. And that is what he has done here. So he moved to round 2. So and his proposal value is B, as we can see here. On the other hand, P3 accepted the proposal from P1, so now he changed his proposal to be A. And the last proposer, the guy that proposed the last time, it was P1, so he said it's P1 here. Okay. Now P2, of course, he didn't care about the value of P1. He just proposed his own value and said, okay, my value is B, and I propose it as a second processor. So my proposal number is 2, basically. And he also decides on B. So here's a situation where we have a decision on A here and a decision on B. Now, let's continue. So what happens here is that P3 suspects P2. So he moves to round 3 and he takes his proposal, which the latest proposal he adopted is A, and he decides on A. So we can see here we violated consensus. We violated agreement. So that is in the case of regular consensus. So let's look again to the execution of the algorithm where we delay the decision, the decide, to the end of the algorithm after we went through all the rounds. And in this case, we are going to have interesting assumptions, which says P2 suspects P1, P3 suspects P2, and P1 suspects P3. But we are doing uniform consensus, so we decide in the end. Still, we have an inaccurate failure detector. Okay, let's see what happens now. So P1 proposes. It's only P3 that is going to accept this, and P2 will move to the next round. That's fine. Then P2 supposed to propose. So P2 proposes, proposal B with proposal number 2, and now, which you can see here, P1 will accept P2's proposal. It has a higher proposal number, and so he will accept this. But B3 is going to move to the third round because, let me see, P3 suspects P2. So P3 is going to move to the third round. Okay, very good. So we do that. So P3 is still accepting only the proposal from P1. He's going to move to the third round. Now, P1 suspects P3, not P2. So in this case, as usual, P3 is going to decide on A. That's the last value it got. It will enforce that value on P2. So P2 also will decide on A. But P1 will going to move to the latest round, and he does not care about what P3 have decided. He's just going to decide in the value that he have got previously. The value is P, and we can see that we have violated the agreement property of consensus. So the question that we're going to ask now, is it possible to have a weaker failure detector than a perfect failure detector? Thank you.